Hello everyone. Today we will explain the misc challenge called busbus. This challenge is a black box misc problem. It has no attachment and our environment is at the address below. It primarily tests familiarity with the Modbus protocol. The challenge description says this device has a backdoor that needs to be triggered to leak sensitive information, where the sensitive information refers to our flag. Then we can try to connect to our target. When connecting to our target, it does not respond without an attachment or echo. Triggering the backdoor typically involves the protocol handshake, special encodings, or traffic characteristics. We can guess what protocol this is by searching for information or asking AI, etc. After numerous attempts, we find it is the Modbus protocol. The Modbus protocol is one of the most common protocols in industrial devices and highly relies on a specific hexadecimal packet structure. If the packet format is incorrect, the server usually discards it without any response. Let's look at our script. This is its packet structure. Let's first introduce this packet structure. First are the first two bytes, which refer to the transaction ID. The next two bytes refer to the Modbus protocol identifier, typically defaulting to 0000. Then this 0 times 00 times 6 refers to the length of the following data. The next byte 0 times 1 refers to the unit ID. And this 0 times 3 refers to its function code here. It's just a simple example, the function code. The following 0 times 00 times 0 refers to its address. The part after this refers to its value or the number of registers, etc. Its meaning varies for different function IDs. After understanding the packet structure to get a clear response, we can try writing a script to brute force it. Of course, for brute forcing, you can use Pebble and tools or the socket library. Actually, the first few bytes here are fixed like length as long as you know the following data. This value is also fixed, so we have the united and function ID. Actually, there are only a few function IDs, 0 times 5, 0 times 6, 0 times 0 each C, and then there's the address. For the address, we can brute force it. Here we can first fix an address to try detecting other values. For the last value, we can also write a fixed value. First, we can brute force the first unit ID value using the following script. For this UID, it's usually like 1 or 255, but for this challenge, the value is not very certain. So we can brute force from 0 to 256, brute force this value, and we can see if there's a response, possibly adding a delay with sleep. This should start brute forcing from 0 times 0. Let's wait for the script to finish. It will take some time. Good. We can see this value has a response. It's 223, unit ID 223. Then we can check if other values have responses. We found an active ID 223. So this value is confirmed. Its hexadecimal is 0xdf. Next, let's look at other IDs. Well, 0 times 3 refers to holding registers, which is reading. And 0 times 5 is asingle. Coil write 0 times 0. F is multi-bit write. So when writing, we can use these two values to write something and see if there's any effect. Let's look at the second script. In the second script, the 0xdf value is confirmed. Then we can first use 0 times 5 or 0 times 0f to write something. Here I directly used 0 times 0f to write the hexadecimal of flag. It writes the values 0 times 66, 0 times 6, C, 0 times 61, 0 times 67. This is function code 0 times 5. This is 0 times 0f. Then we directly write a 4-byte flag. Write first, then read the information. Here, the number of registers we write is 0 times 60, and the step size uses an address offset. I used a fixed 32. Let's take a look at this. Since the UID value is confirmed and the address and the number of registers are uncertain, we can assign a fixed number of registers and brute force the address. Let's run this script. If you don't get anything in one run, you can run it several times, write multiple times. Here we got a flag value, so this challenge ends here. The value here is our final flag.